Right. Hello, Anson and Nicole. Welcome back to the Accelerate for Kids Tech Time Workshop. And of course, I am your technology instructor, Jack Pierre. Hey, a couple things I wanted to show you real quick is I found this cool video about machine learning. And machine learning is definitely a more advanced coding concept. But I just wanted to show you. So we can use programs to learn. And here's an old game for Super Nintendo. It's one of the Super Mario Brothers games. And you can see that there's this Mario going through the world and avoiding all of the enemies that would otherwise kill him. And believe it or not, this is a program that's actually playing the game. It's not a human. And the thing is, how do we learn to win a game? The first time we try it, we're probably going to fail a couple times first. But if you see here, it shows the different buttons on the controller: A, B, X, Y, up, down, left, and right. And we can see that in each moment, it's timing. It's using the different buttons at very specific times, and that allows the computer to navigate past the the different enemies and stop from falling down. So I just wanted to show you computer scientists use things like this here. Let me just try to show you. So computer scientists use algorithms and machine learning to navigate obstacles. So for example, that obstacle could be a level in a game, but also think about this. What if you're a car driving down the road and you want to get from your house to, let's say, the grocery store, and you have to navigate yourself from your driveway to your grocery store? So you might have to pull out of your driveway. You might have to stop at some stop signs and let some cars drive by, and some pedestrians might cross the street, and we don't want to hit our pedestrians or run into any other cars. So we have to make decisions to turn and stop and start and speed up and slow down at the right times, because otherwise we'll have a crash, and that's not what we want. So it's cool that we can use computer algorithms and machine learning not only to beat levels in video games, but also to control our cars like autonomous vehicles. And I just want to show you something else real quick here. So Navya, Navya, they're a company who creates autonomous shuttles. So it's these cars that drive by themselves. And they have these, what they call LiDAR on the top. And LiDAR is like a laser, and it's like an eye. So it's on the top of the vehicle, and it's like eyes. It's looking all around to make sure that there's no pedestrians in the road or any debris. So it's got to go around signs. So what's cool here is the car is using cameras and lasers to see the environment around, and it's taking those pictures and videos, and it's taking the information in from the sensors and the lasers, and then once it sees these things, then it processes what it sees at its brain or at its computer. So when we see things out in the world, or when we see things maybe in our Super Mario Brothers game or other games that we play, we have to navigate around our different obstacles. So there's all sorts of machine learning algorithms, like this basic game Snake. So there's this old game called Snake where you have to go and you have to collect the red dot without hitting the wall, and you also can't hit your own tail. So this is what we're watching here is a computer program play the game Snake, and it's learning how to get a high score. So at first, it's not very good at the game. It dies really fast. But after a while, it learns how to play the game. It learns how to avoid hitting the wall, and it learns how to avoid hitting its own tail. So if you can see, it's almost like turbo mode in Scratch that we're watching. But the snake is kind of going in these big boxes, making these big kind of rectangular shapes in order to avoid its tail. And you can see sometimes when it dies and it has to start over. But over time, the more and more the program plays the game, the better it's going to get at playing the game. In a way, it's kind of like a human mind learns, but it's a machine mind, it's a computer. And ultimately, the computer learns based on how we tell it to learn. It's kind of similar with our brains. Our brains learn based on how we kind of tell our brains to learn. But yeah, I wanted to show you some cool things. This is definitely advanced computer science stuff, but this is just one way that computer science can be used, is to kind of navigate things. And yeah, I was trying to find a good example with these autonomous vehicles. For another example, there's a company called Waymo, who is out of California, and they're creating autonomous vehicles too. And if you see this car here, you can see it has all these crazy attachments on it. And again, those are just a bunch of different cameras that allow the car to see. So right here on the top of the car, that's the laser LiDAR that spins around really fast. And it sends out a laser that bounces off of the things around it. So right now it can see the cars. It's recognizing the cars. And that's a programmer who programmed this car's brain or computer or processor how to think. So it's taking in information from the LiDAR. It's taking in information from the cameras, which are like the eyes of the car. And what it sees, that information is being processed at the CPU, the central processing unit. And as the computer is processing the information, based off of the information it gets, which is the location of the cars and the people and maybe debris in the road. So based off of those inputs, those sensory signals, the car is going to make decisions, and it's going to turn to avoid hitting pedestrians. It's going to, so it asks, what should I do? So this is just kind of cool way to kind of see. And right here is a quick, this is what it looks like for this program to drive down the street. So hopefully this, you can see what's going on here. And we see this Waymo vehicle, and this is what it's showing you what it sees in blue. And then it's gonna go through the intersection. So just to kind of show you that right now this car's cameras and LiDAR, it's seeing all these things in blue, and it's processing the location of where it is at its processing unit or its brain or its computer. And it knows how far away things are. It knows how fast they're moving. So this is really cool how computer science comes together in our world. And in the future, something you could do if you're interested is you could be a programmer or a coder or a software engineer in the automotive industry, and you could help work on autonomous vehicles. So this is just one option that you can, this is one set of problems that you could work on as a computer scientist. Is, all right, how can I get my car to drive autonomously through the world? And just as comparison, it's just kind of cool to compare a real life example to like our Mario game, that it was so a computer trying to learn to play a game versus a computer trying to navigate a car through the actual world. It's pretty fascinating, and hopefully you see the connection there. But yeah, for now, let's move on into our today's activity. I'm just going to get rid of this for now. So I'm going to open up our Google CS first. All right, so let's get ourselves signed in to Google CS first. And once we are here, you're the student, so sign in as your student. Now I'm going to do the teacher. Username and password. All right, and we are in our advanced coding workshop. So let's go to our game design. And I'm just going to check on our progress, see how you all are doing. All right, let's take a look. Very nice. It looks like we're working through day one's activity. And looks like we haven't got much into days two activity yet, but make sure that you are going through and working through all 10 out of 10 of these pages in your activity. So again, make sure to work 10 out of 10. And that's going to make you reflect and learn and do the add-ons and really apply the code the right way. So all right, let's go back into our class. So we are at game design. Let's open it up and scroll ourselves down. So yesterday we were working on that gaming story. So with that gaming story, we were talking about our favorite game character or what character is most like us. So keep working on that until your story's complete. But today we're going to work on our racing game, which is activity 2. So I'm just going to open this up. All right, so for our racing game, today we're going to create a 2-player racing game where we can control the movement of cars or on a track with our keyboard. So right here in page 1, we want to open up to page 1 here. We're going to skip the video for now. Make sure you're watching this and going through this on your own time. Yet for now, I'm going to click the racing game starter project. And it's going to open up for us. Okay. So let's make sure we are navigated to our Scratch. So I'm going to stop real quick and ask you, so are you logged into CS first and Scratch? And do you have the racing game starter project open? So this is where we want to be. And of course, we want to hit remix so it saves. So Nicole's here. Anson, are you here with us on our starter project? All right, Anson is with us. Okay. So let's just study our starter code and see what we have so far. It looks like we've been given 2 sprites, a player 1 and a player 2. And I'm not seeing any code for them. And it looks also like we've been given this stage. In the stage, it seems like we have 3 backdrops. And we got these 3 tracks here, 1, 2, and 3. Now going back to our sprites, player 1, I'm just going to look in the costumes, and it looks like we got an elephant, a unicorn, or a car. So we got a couple costumes with player 1. Player 2, let's see, we got a lion, a dinosaur, a butterfly, and a car. So just to see some of the different options that we have here. So all right, let's take a look. So again, our goal today is to make a 2-player racing game in which players will control movement with the keyboard. So this game is played with 2 players, but you play on 1 computer or 1 keyboard. So how are we going to do that? Let's start thinking about that. So how are we going to program a game so where 2 players can play on the same computer at the same time? And of course, we have to control our movement using the keyboard. So that means both of our players are going to be on the keyboard. So think of maybe what buttons on the keyboard would you utilize for player 1, and what buttons would you utilize for player 2, and how are we going to program our characters to make it to navigate around this track here. So, all right, today we're going to use coding concepts like events, movements, and repeat blocks. And we've used these before, but maybe today we're going to use them in a little bit of a different way. So let me see here. Let's get on to our first step for our racing game. And we got the project open. So first, let's start with our player one, which is this elephant. So make sure you have that selected. And we're going to start by programming player one to move with key presses. So of course, in events, we have our when space key is pressed. So let's grab that and change it to our up arrow. And when we press our up arrow, we want to move 10 steps. So yeah, we've used code like this before. This is nothing new to us. So now we see with the up arrow, we move 10 steps. I'm just going to drag my player back here to the start line. All right, and another thing we can do with events, let's grab 2 more of these key presses. And I'm going to go up to motion, our motion block. And now I'm going to use, let's see, I am going to use this turn 15 degrees. And for this one on the right, I'm going to make it say right arrow, and I'm going to make that 15 degrees in the clockwise direction. And I'm going to do the opposite with the left arrow. I'm going to make that counterclockwise. So let's grab the other motion block, and now this way it's counterclockwise. So now we can turn in both directions just by pressing our keys. So now just try to navigate your character through the course without going outside of the yellow lines. So let's just play around for a second, and you'll notice you have to click a bunch of times. It's really rigid. It's not fluid and continuous. So we have to press a bunch of times to turn. So yeah, we're going to do something a little bit to smooth it out. But right now, this is a good starting place for our code. At least we got our player one moving. And I'm sure that we could duplicate the same code over to our other character and make it work for our player two as well. But for now, let's try to make it so our characters move more fluidly. But real quick, I just want to catch up with you and make sure that you're all with me. So are you able to move, or are you able to navigate your character or your player? Let's call it a player. Are you able to navigate your player all the way around the track using arrow keys? So have you been able to successfully do this? Turn right with the right arrow, left with the left arrow, straight with the up arrow. Excellent, excellent, excellent. Anson, I'm sure you got this, but I gotta ask, are you with us, Anson? I'm sure you're here, but just checking up on you. All right, I'll assume, okay. Anson is with us. Nicole is with us. Jack is with us. So let's move forward. The next thing we're going to do is we're going to smooth out our movement. So right now it's kind of choppy and jumpy, and you have to press the button a bunch of times to get it to work properly. So we're going to implement some repeat blocks and some conditionals that are going to help us navigate the track more smoothly with our players. So how we're going to do this is I'm just going to move these down a little bit. And for now, we're going to work on this top code. So what we're going to do is we have this move 10 steps with the up arrow. And what we can do in control is we can repeat this. So every time we press this, it just moves 10 steps and stops. But now if we repeat until, so let's go down and find the bottom loop says repeat until. So let's grab that, and we're going to put this inside. So see, now it just keeps going. So so it's moving 10 steps forever in a loop. And it says I'm going to repeat, so I'm going to loop 10 steps. So I'm going to continue to move 10 steps forever until a condition is met. But if you look in our box, we don't have a condition. So right now it's pretty much the same thing as if we had this forever loop. So this is pretty much the same exact thing. So if I keep doing this, it should just keep, so forever, it keeps making my character move 10 steps. So we need to create a proper condition that allows us to make our character move smoothly. So of course, we're using our up arrow. So in sensing, if you go to the space key is pressed question and we slap it up in here, so it says repeat until up arrow is pressed. So let's try this. So let's see how this works. So I'm going to grab my character, just kind of put it in the middle so we can see. Right now, we just want to make sure we have control of our character. So I'm going to press the up arrow. And it looks like nothing is happening. So it says, let's see. So now I've activated just by pressing it. And it says repeat until the arrow key is pressed. So right now I'm not pressing anything, but now let's see. So when I press the up arrow, it stops. So play around with that for a second. So press this line of code and it should make your character kind of keep moving those 10 steps. And it's only going to stop under the condition that you press the up arrow, right? So now it stops. So that's not quite right. That's not quite how we want it to work. We want it to go forward a certain amount of steps while we are pressing the up key button. So what we can do in operators, this green, we have this operator called not. So let's grab that. And we're going to take this here, our sensing key up arrow press. We're going to put that in not. And then we're going to put not key up arrow pressed in our condition. And that's our condition that we want. So if you take a look, now when we start, we should be able to press the up arrow and move until we're no longer pressing the up arrow key. So that way you can see at least with the up arrow, the movement is much more fluid. Now we would have to do the same thing for the right arrow and the left arrow so that we can get it to turn fluidly, because the turning is still a little rigid. It's like versus the movement with the up arrow key is more continuous. It's just so just to show you, take a look at our code here that allows us to do this, and really it's all about our conditional that's inside of our loop. So we're familiar with loops. We are definitely familiar with loops. And remember, if it looks like this, it's just like a forever loop. Repeat until a condition is met. But this is our condition. So we programmed our condition to be when we are not pressing our arrow key, we are going to repeat until we're no longer pressing the arrow key. And that's what that line of code says. So let's take this and we can copy it. So I just duplicated it and I'm going to drag one down here for the left arrow. And of course, I don't want the move 10 steps, so I'm going to get rid of that. And I'm going to take my 15 degrees and sneak it inside here. And rather than up arrow key, I want this to say left arrow. And I'm going to attach that. And then the same thing, we can do it one more time. I'm going to duplicate this and I can put it over here. And oh, one thing, check this out. I don't want to turn left, so I'm going to get rid of that. I want to turn right. So I'm going to put that in my loop, and then I'm going to connect my loop. And finally, rather than the left arrow, I'm going to change this to the right arrow. And then once we've done that, so I know that was fast, but once we've done that, now you can see it's much different behavior for our character. So to get the character to turn is much different. So you can play around with, maybe you want it to move 5 steps rather than 10 steps, or rather than 15 degrees, maybe 5 degrees. So play around so get these right. So for your up arrow, left arrow, right arrow, make sure you properly code them. And play around with these values inside our loops. and make it so you can control the character how you want it to. So as you change these values, it changes the speed. So this is a pretty good speed, I think. I have pretty much good control over my player, and I'm able to navigate pretty fast around this course without going through the lines. So let's just take 1 to 2 minutes and complete this code that I have here on the screen. And I'm just going to rearrange it so we can see it all at once. And I'm going to zoom in a little. So here we go. So let's just take 1 minute to play around with this. And I'm going to get myself some tea because my voice is a little sore. And I'm going to be right back. So keep working on this code, and I will come back in just 1 minute and check on you. All right. I got my hot steaming tea. It is seeping here, and it is going to be medicine for my voice and make my voice strong so I can teach you more classes. But I'm going to put that aside for now and let that cool down for a few minutes and check up on you. So, all right. So, a quick checkup. Are we able to use conditional loops and key presses to smoothly navigate our player around, let's call player one, because we're in player one right now. So are we able to use conditional loops and key presses to smoothly navigate the track? Okay. Okay, let me try that again. So conditional loops, key presses, and navigating the track. So have you been able to do this? And using that not command, so we have the not key arrow pressed. It kind of looks like this. So, all right, how are we doing? Nicole and Anson, are we able to navigate around the track? Nicole's got it. How you doing, Anson? Let's see. All right, Anson, I'm assuming you're with us. Okay. All right. Of course he is. Of course he is. So, real quick, let's make it so that we can play with our second player, right? So right now we have code for player one. So player one here has all this code, which allows player one to navigate the track. But now we need to program so player two can navigate the track using key presses. So let's use the code we've already created so that way we don't have to reinvent the wheel. And so we want to get this code here over to be for player two. So just to remind you of some ways you can do that is you can drag and drop the code into your other sprite, and then it is copied there. Another thing you can do is drag and drop code into your backpack. So I have some scripts that I've saved in my backpack from earlier today. I'm going to delete those because I don't need them. But what's cool is I can drag these codes down into my backpack, and they stay with my sprite. So they're still here with sprite 1, but they've all also been copied to my backpack down here. And now I can click on player 2 and go into my backpack and drag this code out and make sure it's not overlapping. So yeah, usually when you drag them out, they kind of overlap. So they might be hiding behind one another. Make sure they're not hiding. You don't want to double up code more than you have to. So make sure, oh, it looks like I've accidentally copied where it says 2 up arrow. So make sure we have one with left arrow, one with right arrow, one with down arrow. So I want to make sure I'm finding the right one. Okay, there we go. So that same code that we just wrote for player 1, we're going to write it also for player 2. But now, take a look. Now they're both going to move at the same time, right? So that's not quite going to work for us. We want to make it so that they're both moving using different keys. So, all right. Let me ask you I know Anson will know this, and Nicole, if you're a gamer, you may know this as well. So with the keyboard in games, how do you move forwards and backwards and left and right other than the arrow keys? What are maybe some other keys that we could use? Yep. Anson's got it. Little WSAD or ASDW. Yep. All right, so let's do that. So rather than the up arrow, let's change that to W. So scroll all the way down to W. And then with the left arrow, let's make that A. And then with the right arrow, that would be B. All right. So now, with my arrow keys, I can move my player 1, which right now is my elephant. And I'm just going to park my elephant right over here. And now experiment with your WASD. Oh, and of course, I forgot to do something. So in our conditions, so remember our conditions here, we have to change that to the right key as well. So make sure that they match. So for W, when we press W, we want to keep moving forward until we press it again, or until we're not pressing it any longer. And the same thing with A. When we press A, we want to turn left by 5 degrees or counterclockwise by 5 degrees until we're no longer pressing A. And same thing with B. When we're pressing B, we want to turn right until we're no longer pressing D. Excuse me, I think I used, yeah, that should be D. I'm sorry, not B, of course. So we have W, A, and D here. W should make our player 2 go forward. D should make our character turn clockwise. And A should make our character, or our player 2, turn counterclockwise. So now you could go get your sister and say, hey sister, let's race really quick. Let's race around the track. And you could both use the keyboard. One of you could use player 1 and use the arrow keys. And then one of you could use player 2 and use WASD. And now you have a 2-player game on the same keyboard on the same computer. So that's pretty cool. Now you have the ability with Scratch to create 2-player games on the same keyboard. And you can play them with your friends or your brother or your sister or your family, like your parents or your cousins, or anyone in the future. You can add effects to this game and enhance this game and make it better. And you can play it and show off with your friends and see how skilled they are at running your program. But let's see what else we can do. So for now, we have gotten player 1 and 2 to move, and then we used So we got them to move using key presses, and then we use conditional loops to make our characters move more fluidly or more smoothly. And let's see what else we can do. So, all right, how about changing the course or changing the backdrop? So that's something else we can do really easy. Let's create a new sprite that changes our backdrop or our setting. So what I'm going to do is go to choose a sprite, and I am going to go down. I'm going to use this green button. So it says button 1. I'm going to take that and put it right in the middle. I'll put it in the bottom right. And I think this is a little too big. I'm going to go and actually make this smaller. So it's 100. I'm going to make it 50. So it should shrink. Yeah, that's more of a better size. So I have this button at the bottom right of my screen here. So this button 1 sprite, and I've kind of dragged it down here, and I resized it right here just by changing its size from 100 down to 50. And another way you could do that if you wanted to, you could select the sprite and then just make it smaller or make it bigger. That's up to you. But make it the size you want. Put it on the screen where you want it to be. And I want it at the bottom right, so I'll just put it there. And now a little quick thing we can do is go to events. And when this sprite is clicked, we can switch our backdrop to a different track. We could say the next backdrop. So now every time I press this sprite, I'm going to change the backdrop. So we have these 3 different maps. So if you wanted to go into the editor, so let's see, if you wanted to go into the editor and create your own level, So if you wanted to create your own level, you could do that here just with paint in a costume. And you could create it from scratch or no pun intended, if you get that. But I'm going to duplicate this and drag it to the bottom. That's another way. So I made a duplicate of track 1 and I dragged it to the bottom. And if I wanted to make some changes to this course, now here in my editor, I could do so. So it's cool. Let's see if I wanted to select all. Let's see if I can select everything. It's a little big here. Wish I could shrink it. Let's do this. Zoom out, zoom in. Now, all right, it's taking up most of our screen, but hey, see if you can figure out how to make your own track. So for example, let's try this. So I'm going to go to paint. So I'm creating a new one, and let's call it track 4. So in the costume, I'm going to call this track 4. And something I could do either in bitmap or vector. Let's see, I'll work in vector for now. So I can change my background fill, or should be able to change my background fill to green. Let's do it as a bitmap. There we go. So now we have this green background. And now what you could do is you could use the paintbrush to draw the outline of your track. And we could use that same kind of yellow color. So I'm using this yellow color. And now let's say we could do this to create our track. And I'm going to try to create a complicated one here. So let's see. So I got this track. This is the outside of my track. And now I have the inside of my track. So I have this wacky track going on. You can create whatever you want. Hopefully yours is a little better than mine. But here's my outline of my track. And then it looks like we have one more color here for the ground, kind of this gray color. So we can choose more of a grayish color. So let's see. Just play around with the brightness and the saturation and get the color that we want. So I got this gray. That looks like concrete well enough. So I got that. I'm just going to fill in here, and bam. Yeah, maybe I'll make it a little brighter if I can. Let's see, make that a little brighter. All right, saturation. Okay, that looks about right. And then I could, let's see, get some text and type start and make it yellow again. Oh, that's not what I wanted. I wanted it to be yellow. And you can kind of grab this. Oh, I lost it. Here we go. I want to drag this to the right place. Let's say I want to start this map right here. I can kind of turn it. There. Let's keep it kind of in the same area. Or, I don't know, I'll just put it down here. So there's my starting line. I can turn it back to yellow if I want to. So this is a way you could make your own tracks for this game, just like track 3 and 4 and 1. So I just wanted to show you that you can make your own tracks, and that maybe you can figure out a better way to make it better than mine. And something else we could do, definitely more complex code. We could code so you would have to stay inside of the yellow lines. I can go check. That might be one of the add-ons. Let me see if that is one really quick here. Because that would be cool if it could keep us inside of the yellow lines. All right. So let's jump back. Stay here, but I just want to go back to our starter project, or our add-ons for this activity 2 here, and just see. Okay, so yeah, I don't think it has the directions for how to stay in the yellow lines. That's something you'd have to figure out on your own. But the next thing we can do that's simple enough for us, because with each of our player sprites, player 1 and 2, we've been given these different costumes, right? So for this next code, let's create the ability to change what vehicle or character you are, or the costume. So if you're player 1, you could be the elephant, the unicorn, or the car. If you're player 2, you could be the lion, the dinosaur, the butterfly, or the car. So real quick, let's write a quick code that allows us to change our character. So how about this? For player 1, let's get player 1 selected. And we're going to work on player 1 first. I'm just going to scroll down here so we have a little room underneath the code that we've created. And I'm going to go to events, and where it says when the key is pressed, I'm going to grab that. So this is player 1, so I'm going to go to the number 1. And when we press the number 1, we can go to the next costume. So that's just a quick, simple, easy way for us to change the costume with our keyboard. So now when I press the number 1, I can change my player 1 costume, which is pretty cool. And similarly enough for player 2, let's click on player 2. I can go down and let's see, under events, when I click, or when I press the number, how about 2 for player 2, I can switch the costumes. All right. So now what we got so far is we have our 2 characters. They can turn, they can drive on the track. We can adjust their speed to be faster or slower, to turn faster or slower, to move forward more fast or slower. And not only do we have player 1, which can change costumes and move, we also have player 2, which can change costumes and move. So of course, if you wanted to get a different costume for your player, you could go into your costumes for your player sprite and down and choose a costume. You could find and use any sprite that you would want. You could even upload your own sprites or pictures of yourself. Or maybe you take a picture of your car and then upload a picture of your car into the game. That's something you could do. So yeah, that's a pretty good code for us. We got a good foundation, and you could build all on top of this. So there's only 5 minutes before I have to transition to my 3 o'clock class. So I just want you to go and look at these add-ons. And we have done change your racetrack, this first one here. We've also done costume change. So after we're done here, after we move on, I want to see if you can go and do crashing sounds, race fans, and color trails on your own. And then I'll check up with you tomorrow. but especially this one, color trails. If we had more time today, I'd work on this one with you because I think this is really cool, and it just allows us to add some more effects as we're going. And maybe you could figure out how to program a power up on your map. And if you hit the power up, it could speed up your sprite and make it go faster than the sprites without a power up. So those are just some ideas for you. But again, I'm going to have to stop with our activity for now and encourage you to work through this on your own. So make sure that you are going in through our game design each day and working through the game story. So make sure you completed this from yesterday, and also make sure you are doing the racing game. So tomorrow when we catch up, we will do the maze game together. But before we do this, before we do the maze game, I want you to work all the way through your gaming story 1 and your racing game. And you could even look into the maze game too. So that way, by the time we meet tomorrow, you're all done with your gaming story and you're all done with your racing game, and you've maybe even taken a look at the maze game. And with this maze game tomorrow, we're going to figure out how to program our sprites to stay in the lines. And once we've learned how to make our programs stay in the lines, maybe we could even jump back and take that code back into this game and make our characters stay in the yellow lines. So here is our conclusion for today. Go test out your program with your brother or sister or your mom or your dad or someone else that's around in your family, and do those add-ons, get some enhancements going on. And also, again, remember to go back to that gaming story and finish your story about your favorite game character or your favorite game or app or whichever you are choosing. And maybe tomorrow, if you'd like, we could take a few minutes and you could present the gaming stories and we could see each other's gaming stories and how they're complete. But hey, for now, I am going to jump over to my preparing for my 3 o'clock class. So I will let you go from here. And again, just make sure you're making progress on each of our activities. So real quick, I have time for one question for each of you. Do you have any questions? Okay, what's that? What's that answer? What's your question? All right. Hey, and if you want, you can both unmute yourselves for now. We're at the end of class. We can talk for a minute if you'd like, if that's easier.
All right, yeah. Do you have any idea how to keep them on, like how to start to keep them on the yellow, away from the yellow lines?
Okay. Yes. Let me see if we have time to do this really quick. So you know how you can click on a sprite when it's on your screen and drag it around?
Yeah.
Okay, so I'm going to go back to stage 1 where we have this start. So I'm going to drag my sprites right to this starting point. Now look underneath. You see this X and Y, -10 and 123?
Yeah.
That means we're right here. So this is what you're going to do. You're going to place your sprite where you want it to start. And then we can use the motion go to block where it says go to. So let's do this right at the beginning. So how about this? When we press our green flag, let's do this for both of our characters, players 1 and 2. So I have this green flag, and place them where you want them to be, so up by the start. And now what you can do for each character is go to motion, and where it says go to XY, let's bring that in and put it right under our flag. So now every time you press the green flag, it should send your character right back to that starting XY position. So now watch me on my screen. I'm just going to move my players to random places on the screen. And then now I'm going to press the green flag and they should go back to the start. So 3, 2, 1, press. And now they're back at the beginning. So another issue I'm having is they're not rotated in the right direction. How you can get it to be facing the right direction is where it says point in direction. You can also bring this underneath and do that for both of your characters and play around with that to find it and face the correct direction you want it to face. So again, now I can go to anywhere on my screen, but when I press my green flag, they're going to go back to the XY position I programmed them to go to, and then they're going to turn in the 90 direction. So Anson, does that answer your question?
Yes.
Awesome. All right, I got time for one more quick question if you have it, Nicole or Anson. One more quick one.
No.
All right. So, hey, thank you for joining me today. Was this a cool program? Did you enjoy it?
Yeah.
Yeah? Okay. Have you ever made a program quite like this, or is this new for you?
It's no.
It's new for you. All right. And yeah, what we're doing here, it's basic code, but you can see how it does get a little complex. But the more we write these basic codes, the more we get the hang of it, the more we'll be able to improve upon it. But hey, I'm gonna say goodbye for now. Anson and Nicole, thanks for coding with me, and I will see you again tomorrow.